A very good day to Dr. Q and Prof. Suji. We are from Group 7 presenting manufacture of instant tea using leaching process. This is our group members Fakir Salahuddin, Nur Nabila, Shahir Haziq, and Nur Ain. Introduction. Instant tea is made from black, green or oolong teas, all of which originate from the same plant Camellia sinensis. The difference between the various types of instant tea is based on the method used to produce them. Instant tea can also be produced from the waste and leftovers generated in the leaf tea manufacturing process. The process of making instant tea involves extracting the solids from tea, clarifying, concentrating, drying the extracted liquid to form a powder. Next, I will present instant tea production process. Firstly, extraction or leaching process. Tea leaf fed into lower end of the extractor and conveyed upwards by the rotation screw while hot stream flow in the upper stream countercurrently. The second process is separation or decanting process, used for separating large volumes of inseparable tea leaves components from tea extract. Use centrifugal force to separate the solid from the liquid efficiently. Next is aroma stripping. Volatile aroma compounds are separated from the extract before or during evaporation. Next is spiration. The second spiration is sedimentation process. A centrifuge is utilized to separate fine particles from the extracted tea liquid. Operates based on the principle of sedimentation, where denser substances and particles are pushed outwards in the radial direction due to centripetal acceleration. Next is evaporation process. The liquid obtained from the decreasing process is too dilute. It needs to be concentrated in a range of 25 to 50% solids. For the last process is blending and drying process. Blending is concentrated tea liquid mixed with aroma compounds. Drying using spray drying method. Concentrated tea solution is fed into the drying towel by a high pressure homogenizing pump and then sprayed as fine droplets into a current of heated air. This is the process of the production of instant tea consists of the following operation. The raw materials, which is tea leaf, will enter extraction operation and produce insoluble tea leaf. The insoluble tea leaf will enter separation operation, then produce aroma and extracted tea liquor. The aroma will keep in aroma stripping, while the extracted tea liquor will enter the second separation operation. After that, it will produce tea liquor where the tea liquor will enter the evaporation operation to produce concentrated tea liquor. The concentrated tea liquor will enter the blending and drying operation with aroma from the aroma stripping and produce tea liquor, where it will straight to the packing operation. This is the block flow diagram for the whole process of manufacturing instant tea.
For this project, the major separation process is leaching. In the manufacture of instant tea, leaching is a process in which the tea leaves are steeped in hot water to extract soluble components such as caffeine, tannins, and flavonoids. The tea leaves are typically crushed or ground to increase the surface area for extraction. Tea leaves act as rich solids enter the countercurrent extractor and move out through the underflow stream while hot water will act as a solvent. Hot water will pass through the extractor and become a tea solution which will pass through the overflow stream. Next, the water temperature and steeping time are carefully controlled to ensure that the desired components are extracted while minimizing the extraction of bitter or astringent compounds. The water is then removed, leaving behind a concentrated tea solution. The tea solution is then dehydrated through a variety of methods such as spray drying to remove the water content and to convert it into instant tea powder.
Now moving on to the next part, which is number of equilibrium stages. Here some assumptions are made in order for us to do some calculations. Here are some assumptions made. Firstly, this amount of solid tea leaves are being fed at the beginning of the process. Secondly, a set of data of equilibrium line are being assumed in order for us to plot the graph. Thirdly, based on some research, tea-leaf leachings were done in static batch system, thus our overflow solvent is not fresh and has a mixture of solute. Lastly, we need to do iterations and calculations in order to obtain this range of number of stages. Here are the general process flow diagram of multistage leaching. We will then our calculations part by part. Firstly, in our underflow input streams, here are the assumed value for our solid, and solvent, where in underflow input stream L node can be determined with its graph, with its coordinate Y node and N node. And here are the calculations and the values that we obtain. Next is overflow input stream. At this stream, there is no presence of solid B, thus our value of n plus 1 yields 0. Parameter Vn plus 1 can be determined using the calculation and would give the coordinate as follows. And thus, we would conclude that Vn plus 1 lies on the horizontal axis. In addition, value of m can be determined using a variability balance by equating the inflow stream and the outflow stream. Now moving on to the next stream, we assume the values of A solute and B solute as follows, but we do not know the value of solvent, thus it is hard for us to locate Ln coordinate. But as we know, Ln lies on the graph and have the ratio of Nn and Yn, and the ratio is 13.333. Hence, a dashed line through origin 0, 0 is plotted with the slope of 13.333, and the intersection point between the dashed line and the equilibrium line will give us the coordinate of Ln at Y, En and Nn. Using the coordinate values of Yan and Nn, we could find the material C. And here's are the calculation for our underflow output stream. Next, we will find the last stream, which is overflow output stream. In this stream, V1 and its coordinate can be determined. In order to find the value of x1, we use composition balance, and similar to overflow input stream, there is no presence of solid B. Thus, our N1 yields 0. And here is our V1 coordinate.
For the final part of the calculation, we need to plot the graph to determine the number of stages. And then, so this 4 value was obtained from the previous calculation. And then, we need one more coordinate, which is triangle coordinate, to connect the two operating line, which is XA and N. The XA and N, we can find by using this formula here. And then, we can obtain this graph. So this is our procedure to determine the number of stage for multi-stage countercurrent leaching of tea leaf. And so first one, we must start from a V1. We need to make a line and connect it through equilibrium line, and then connect it through the triangle point, and then we repeat the step just like the previous one. We start from here to here, and then we connect it through triangle coordinate. The step is repeat until it exceeds the Ln line. And number of stages are count based on the line made before Ln, which is this one, which is here to here, and then 2 and 3. Line construct after Ln was calculated using the lever rule, which is here. And then the total number of stages is 3 plus 0.3 over 1, which is 3.3 stage. So approximately we need a 4 stage for this multi-stage counter current leaching of tea leaf. So that's all.
Now we look into some parameter changes. Here with the same condition, we only change the feed flow rate by decreasing it by half, and we could see we got lesser number of stages.